Okay, so welcome back to the Slapdown intake series. Last episode we dropped these two plates. That one's going to support the motor. That's where we're going to mount the motor to. This one we're going to mount like a gear going from there to there, and then a chain driving pivot. Today we're just going to finish off some sketching. We're going to add like a hard stop, we're going to add a spacer for the chain here, we're going to add how we're going to mount the motor, this motor that drives the rollers. Anything else? I don't think so, and then we'll go into assembly. And then at the end, when we're happy with the positions of all of our components, that's when we're going to pocket, right? Because if you pocket now, it's just moving things around, it's just not fun, you probably have to re-pocket it. Okay, so what I will do is start off with a hard stop. Now the hard stop is going to be mounted onto these holes, and that's why I drew this part here, because that kind of acts as, it hits against the hard stop. This face and this face are going to sit against the hard stop that's like mounted on this part here. So what I will do is I'm going to add a fillet to here, and I'm going to make it 10 mil. I'm going to make it a pretty big fillet. I'm going to also add a fillet which is smaller to all the other corners that aren't filleted. So this guy here and this guy here. Just so it's not sharp, give it a nice round edge, looks nice. Okay, anyway, back to this. I'm going to start a sketch on him. Go null. So now we can, this position here is the position where the intake is down, right? Now, if I was to draw a hard stop now, like this, that wouldn't make any sense because the intake wouldn't be able to drive backwards now. So I kind of need to understand, like, what does this plate look like when it's stowed back, right? It's kind of hard to imagine, but you'll see in a second. So when the plate comes back, these holes will rotate. Let's see, it rotates around 85 degrees. So that hole is going to be hidden behind this plate. This hole, hard to say. Oh, actually, not hard to say. That's definitely going to be like over here somewhere. This hole is going to be over here, and this hole is going to be somewhere over here, right? So we can use this hole, and this hole to pick up our hard stop. So I'm going to click use and use those, and I'm going to project them. Yeah. At the same time, this guy is going to rotate as well, so I'm going to use him. Oops, what just happened there? Okay, weird. Don't know what I pressed. Oh wait, I'm going to turn on Karnak. That's just the keylogger. Okay, and I'm going to make this Q construction line, and this guy is also going to rotate, just so that I can have some points of reference. Oh, also because we're rotating it back, we also need to pick up this guy over here. How do I explain why? Because our hard stop is going to hit against this, and if we're drawing our hard stop relative to its back position, we need to bring this guy back too. You will see in a second, but pretty much I'm going to do a circular pattern. Circular pattern of this, and this. Looks really weird now. Two of them. The angle that they're going to sit at is 85.831. 5.831. Right. Okay. So pretty much like this line is that line 85 degrees off. This line is that line 85 degrees off, and this line, these two plates are the sides of our intake plate. and this plate is our gearbox. This side is our gearbox plate, and all of these holes are we're gonna pick those up for our hard stop. So I'm actually gonna turn off the construction geometry on those guys. You can just click them all and press Q. I don't know why I did it individually for each one. But essentially, now that I've got those hole positions, I can draw out, you know, I definitely want my hard stop to sit along this line. Right? It's going to sit along this line. It's probably going to come down to there. It's going to sit along there, because that's what it's going to hit. It's going to pick up this. It's going to... It's going to sit... Where are you going to sit? Well, this guy needs a clearance, because if you remember, we were putting a bearing here, and the bearings are flanged, meaning they have a... I don't know how to describe a flange. It's probably if I just show you. They have this edge, right? So this is just the outer diameter of the bearing, that race there, but it kind of extend out a bit. So I'm just gonna make a center point arc around here that goes from there all the way to here, I guess. And I need to make sure that it doesn't touch the flange. So I'll make that like, I don't know how wide the flange is, but I'll make that 3 mil. Hopefully that's enough. We'll see in the we'll see later. Yeah. Then this can probably come up. I need to figure out how exactly I want to constrain it. So it doesn't really matter, to be honest. I'll put that there, put that there, put that around here, because remember that's the edge. That's the edge, that's this plate, 85 degrees up. This one is going to come here, and I'll draw a line in between them. Is that what I want? Oh, I guess that's not good. I want this to be a set distance away. Go for 3 mil. Yeah, now I just need to work on like how I'm going to constrain the rest. So this one maybe can be parallel to that line there. No, I'll put this one that also turned away. This guy needs to also be dimensioned. Let me think. Is it just the angle? Is that all I need? Yeah, it is. Okay. Sick. And I can extrude that guy out. So that's gonna kind of like act as a hard stop, right? Actually, make that new, because you can pick either new or add. Add means it adds it onto this plate. New is a completely separate part. Another thing is, it's picked up holes that I don't want. Now I was sure I made them a construction line, but yeah. Okay, this hole and this hole and this hole need to be filled up. And now I'll just fill at the edge so that it looks a bit nicer. Okay, yeah, sorry about that. Okay, so where were we? Okay, so maybe I can change the shape a bit. I kind of want more material on there for the hard stuff. So what I'll do is, I'll get rid of the parallel constraint and I can bring this guy in a bit. I'll probably set the length of this. So the way I did that, the way I can do that, see it's trying to select the construction line. I just hold over that and I can select, you know, I just press that and I can select the other ones. I don't know, I can make that 20, maybe 30 maybe. Yeah, good enough. And then what I'll do is I will fillet the rest. So fillet, try to keep the one fillet feature for a single part. You know, don't use the fillet feature in multiple parts. It just makes things a bit more complicated and confusing. Yeah, just like that. So now, like, yeah, when you put this on, it should, if I was to bolt this to there, this to the one over here, this to the one over here, that side should be hitting up against that, and then in its back position, that will hit against this. Something I will note is like our master sketch that determines this angle, but we've set the angle here. So if we were to change our master sketch and change the angle, we would have to change the number here manually. It's not optimal. Maybe you could like make this a driven dimension, not like a regular dimension, in a variable studio that's, you know, global, so it works for both, and you could go and use that variable here, so it updates in both. But whatever, doesn't really matter. I can do that manually. Though you probably should, so you don't forget it in the future. Anyway, moving on. Remember that we have a sprocket here. The sprockets, I go to the sprockets, they're just a plate. They look like this. Not a spline Excel, not that hole, but it's essentially a plate, right? So that's an issue because the chain is wider than the sprocket, and right now if we were to just bolt the sprocket onto this plate, it would hit the chain would just hit the plate because the chain is width, it's wider than the sprocket, like I said. So we've got to offset a little bit. So I'm gonna make a sketch on this face, and that sketch is gonna have some diameter, and it's gonna pick up these holes. Use those holes. Am I recording? Yep. Like that, and I will have that 3mm away. I want to up that later. We'll just 3D print this part. It's not a big deal. Actually, oops. I'll also use the bearing ball. We'll just 3D print this part. It's in compression, so it doesn't need to be particularly strong. Make it new. I don't know what it has to be for now. We'll make it like 2.5mm. It really depends on like the width of the chain, right? The last part that we want to prepare is how we're going to mount the motor. So the motor, like we said, it's got these 4 mounting points, and it needs to be spaced out so that we can put a pulley and belt going to the rollers. Now you could do 4 spaces, but that's 4 parts that need to be machined. It's you know, when you machine things, you try to make it within tolerance, which takes time, and time isn't really something that we have during the build season. So instead, let's try to think of another solution that we can 3D print. Something that a lot of teams are doing now is they're just printing the motor spaces, because like this part, it's in compression, and it means that you reduce your part count from 4 to 1, and also what was I going to say? And also it's 3D printed, so it really takes no like machinist time to make this part, which is great. So I'm going to use a center point arc, and it's going to go, sorry, all these, construction line that. Remember that there's a belt running here, this way, like that, to the roller. And what that means is you can't have this, you know, this mounting arc thing go to this hole here, because it'll hit the belt. But we can put a spacer there. Some teams, they don't put a spacer there at all. Some teams, they do. I don't know. Your choice. Then we can go slot tool. Like that. What should that be? I don't know. 10 mil? Yeah, good enough. And I'll extrude that out. Again, new part. How wide should that? How long should that be? This depends on the shaft length. Because if we want to be able to put our pulley here, and we don't want our shaft to stick out too much out of the side. So I'll make that 20 for now. We can adjust that later. Now I think we have all the parts we need to start assembly. Awesome. So let's go into the assembly. This guy here, and let's start to insert parts. So I'll insert everything. Just click on it like that, and just place it anywhere. Click the tick. Now what I want to do, you can see nothing is actually constrained, like this. First thing I probably want to constrain is this like mock drive base, so that they stay together and they're fixed in place, because right now you can move them around. So I'm going to select all those parts. That. Oh, that's not good. See how part 2 is all of this together, including the gearbox plates? Now, these are actually supposed to be different parts. So I'm going to go back into my part studio, and I'm going to change those to new. Same as this one. If you caught that before, well done. Hey, okay, that's not nice. I'm going to insert everything again. Okay, so now I'm going to select all of my drive base related components. This, that. Is that one? No, that's my gearbox plate. And I'm going to group them, which means that, group, tick. Now they stay together. They're kind of like constrained and placed together. And then I'm going to fix this. Just, you right click on any one of these parts and you click fix. Now I can't drag it around, which is good. I can drag these ones around, right? So I can start to constrain them. I guess I can use a fasten mate. Now what a mate is, that's how you connect two parts together. A fasten mate removes all degrees of freedom between two entities. So you can see when I hover over it, it's called a mate connector, this circle comes up, and it's literally just a coordinate axis. You can see like X, Y, and Z. And what a fasten mate will do is it will put those two mate connectors that you select together, and it will align their axes. So I'm going to click on this, and I'm going to click on this, right? And I'm going to see if that's what I'm happy with, what I want. So yeah, that's exactly what I want. We'll do the same thing for this plate. Bang, bang. Nice. Okay. Next thing we can probably fasten is this guy, right? Now that's not exactly what we want, so we can try spin it around. Still not what we want. Now it's probably because of the way that I drew it. You know, I had to like I did the circular pattern thing. You could probably do it the other way. You might be able to figure out a way to actually use the holes instead of like circular patterning them. See, it doesn't align here. But what I will do, I don't really know how to do this properly in Onshape, to be honest. Maybe there's a good way to do it, but I came from like a SolidWorks background, so we didn't actually have this fasten mate. We would have to use these ones together to fasten everything together. So I'm just going to do Revolute Mate on these two. If I click tick, you can see that now it can, oh god, it can spin around. Yeah, it can spin around like that. But then I can do like, I don't know, can you do another Revolute Mate? Nah, doesn't like it, but I can go and select cylindrical maybe, solve. No? Are you kidding me? Oh god. Hmm. I'll deal with that later. Like I said, I don't really know SolidWorks that well. I mean Onshape that well. I can fasten this and this, because I drew those together. I can fasten those. I can make this revolute, this plate, revolute to that. Yeah, let's do that. This one, revolute to this. So now it's revolute, but I'm gonna have a bearing there, so I need some clearance. I'll offset it by about 3 mil. Make that negative. But the thing is that using that offset isn't great, because it means that using that offset isn't great because it means that what I should be doing is putting parts in here, and then the offset is determined by what's in here, washers and whatnot, and the bearing. But I'm just trying to get this not to move right now, so I can line it up and play with it a bit. So those definitely line up. Now, how would I? Dang it! How would you do this? Did that work? Oh, perfect. That worked. Cylindrical. I don't know. Like I said, I'm sure there's a better way to do it. Pretty much, I can go to my revolute, and I can go to limits. Let's say can that be 0? Yep. And then the other side is going to be 85.831. And I can spin that back. You can see now it's going to hit the hard stops. That's exactly what we want. Now, the thing is, I kind of made a mistake before. What I should have done is made this also use the bumper as a hard stop. The bumper is a great hard stop because it's made out of foam. It's going to keep your polycarb plate safe. It's not going to cause too much harm on it. And it's just always there. It's such a good hard stop. But this, you can do 2 of these in combination so that if you don't have your bumpers on, it still works, or I don't know what. This can be made out of aluminium 6mm if you're confident in your software team to not drive it into this aluminium plate and break them. It could if it drives really hard, it could also snap this plate. It could also be made out of TPU, but that wouldn't put it if you make it out of TPU, it means that this is relatively flexible and it can come back further than what you've designed for, and vice versa. That's why it's also great to have the bumper, because the bumper is just such a solid piece, hard stop. It's foam. Yeah, you'd have to figure that out. Okay. Moving on. What's next? We've got all of that. Let's start to put in components off the shelf parts. We call them COTS. Let's put in the plate sprocket. So we're going to be using a 36 tooth. God damn it. 36 tooth sprocket. This guy here. Yeah. What's the difference? Oh, right, this is okay. We might actually have to change our holes, because I think that in the first video we used the max spline, these ones. I think we based it off this one, but I don't think this is compatible with a hex bearing. So what this is probably not going to work. Yeah, I'll do a revolute for now, so I can spin around. But what I'm trying to say is if I was to, these holes aren't going to be aligned. So I'm going to find out what the center distance is. That's just the bolt circle of those holes, right? And I'm going to go into this plate, and I'm going to go and modify that to that number. That's the Andy mark. Andy mark is another distributor. Oh, this fillet's broken. when you've got a broken fillet, it comes up like that. So I'm just gonna do that. Delete it and do that. Hey, that's not what I wanted actually. Hey, that's not what I want. Oh, it's because it's like, it's clipped by this. So I need to jump into the extrude that out. And now I can fill it. This. Perfect. But yeah, if I go to sprocket 36 to 25. 25 series 66. Nah, that's not what I want. That's not what I asked for, bro. This guy here. Bearing bore, plate, sprockets. They don't have a 36. Don't worry about it. We can always just machine this ourselves if we really wanted to. But it is always better to buy them because they have the chamfer. Okay. I will go and... Can I revolute that? Do I have to use cylindrical again? Yeah, it's not broken. Sick. Awesome. So I've got that. I can probably put the bearings in there that I wanted. So, bearings. Well, I'll just go to my favorites, but it's this guy here. 0.5 inch hex. You can look it up. So, got that. And I will fasten that to that. Copy that. And fasten again. Let's have a look that it's all good. What we can do is use the section tool. So Shift X brings up the section tool. I can click on this face and drag this in. Tick. So you can see here those bearings are actually colliding. That's really not good because that's not going to fit. I don't know about how much they're colliding by, you can't really tell, but the way that I can fix this is just making this guy thicker. So I can go into my Part Studio, extrude this guy out a bit more. Let's go 3 mil. Is it already done? Should update at some point. Yeah, it is. Dang it. Okay. I will bring him out a little bit more, I guess. 4 mil. Still not good. 5 mil. So there's a little gap there. That's pretty good. Sick. Sick. What's next? Let's do the hex that goes here. So the hex that goes here, what we're going to do is we're going to tap the end of the hex, so put a thread in it, and then we can just have this hex that's sitting in the plate at all times, and then you just like put the intake plate in, put a bolt in here, and that like secures it. So, MK CAD, we can go to hex. If you go to, you can see 1/2 inch hex shafts configurable. Effective length of this guy should be the length from here to here. That's 18 millimeters. The retention on one side is actually going to be a bolt and a washer. On the other side, I know Ben will want me to put a circlip in, so I'll leave a circlip. But yeah, snap ring. Yeah. We'll let that insert. Is there any benefit to circlip over a bolt and washer? I guess not. It's fine to put a circlip here. I just think that it's a bit more time consuming in terms of like lathe operations, but it's pretty worthwhile if you can do it right, because you don't need Loctite. You don't need to make sure it won't come off. It's a pretty reliable shaft solution. So you can see it comes up with the mate connectors that you can use. Now, It's not really what I wanted though, because let's see, is there like snap ring? No, why would I do that? Okay, whatever, doesn't matter. It's not, this isn't right. You'll see in a second why. Literally 1 second. If you were to fasten this to there, no, sorry, wrong side. Fasten that, god damn it. This to that mate connector. Flip. You can see like the bolt is not sitting in the right spot, which is fine, like the shaft length is correct. It's fine. But I will put in a bolt there. So that bolt should probably be that length. What is the length from here to here? 26. I don't know, I'll get like a 20mm bolt or something. Let's go DIN 912 M8. Actually, I want a button head. They don't have button head in DIN. It's really weird, honestly, with the Onshape standard content. But if you go to ISO, you can get a button head. We'll go M8, 20mm. You can also just click here and then auto size, and it will find like the right size. But insert. And now I've got, where is it? Oh, right, because I selected like the edge here and I clicked insert, it just automatically snapped to it. That was nice. Keep in mind that this isn't actually correct. What I mean by that is like this hex shaft, that like script that makes the hex shaft, it makes the hex shaft in a diameter 5.1mm. Not really what we want. We wanted like something that you can tap to M8, but I don't think there's any way for me to like change that. See, when you make the drawing and you give it to the machinist, just make sure that you've changed those numbers, like M8 tapped, all of that. Okay. What's next? Let's move on to putting in the gearbox, I guess. So, Max Planetary was the one we said we were using. We're using a Neo Vortex. We said we're using a 9:1, but there's actually an issue. Sorry, output will be 2-inch. There's actually an issue with the Max Planetary 9:1. If we remember on the website, you can buy a 9:1, right? But when you import it, it gives you like a 2-slice, which, yeah, it thinks that you're combining a 3 and 3. Maybe this 9:1 is a new thing. I don't know. See, it's 2 slices. 1, 2. I'm just gonna change the configuration to, oops, what is this? Wrong button, wrong button. 3-inch. So now it should update to, yeah, 1 slice. Next thing I will do is, next thing I'll do is I will fasten that. So, fasten. So it's put up like main connectors for me to fasten. I don't think it'll work too well because you can see those main connectors are aligned like that, but I've kind of got my, pretty much the way that we've drawn our holes here is different to the way they've got their main connectors lined up. So what I'll do is I will pick, thought about it a bit, I realized how dumb that was. What I can do is I can just revolute the center, revolute, solve, and I can just rotate this to the right position, something like that, right? And then I can revolute him and him. So now that's mounted. Just gonna check that I can still put in my spaces. Yeah, and it's not covering anything. Perfect. you know what, let's put in the spacers now. Spacers. Nylon spacer. This guy, right? The length of it, well, that's definitely 25 because the box tube is 25 mil length. 25. It's going to be a 5.1 millimeter ID, and the OD is going to be 10 mil. And I will fasten that. Yep. Cool. Suppose I could also put some more bearings in. So, copy this guy over. Fasten this bearing to here. Same thing with that. The reason I put the flange on this side is because if I was to put the flange on the other side, the bearing would be able to pop out and just go along the shaft. Yeah. Did I just add a bearing? Yeah. Yeah. Okay. This guy, I think I'm going to need space in here, so I'm going to put the bearing on the outside. Cool. Let's put the gears in, I guess. So I can't remember what we said the gears were going to be. So I'm just going to go into this sketch. Have a look at this number here. 44 and a 20. Easy, simple. Here. Oh wait, what am I doing? 20T gears. That one. And then a 44. This pocketed one. Yeah, let's use the pocketed one. We should buy these anyway. And then what else do we want? 4420. Got us. Oh, we need our 18-2 sprocket. X4 hub. No, it's this guy. Okay. So first things first, I can put this guy in. He can sit right up against the bearing, like there. Then I can put him in, and he's going to sit also against this bearing. So that's great. Love that. But this guy needs to sit with its face kind of like, it's called planar, which means that this face and this face need to share the same plane. Like that, right? So what I'll do, these get kind of messy and cluttered, so I'm going to right click on this mate connector and do hide all mate connectors. I'm going to do fasten this to that. Not good because you can see it's broken our planar mate. So I'm just going to try flip the fasten. No, I need to flip the planar. And maybe also the fasten. No. Fix that. So it's like sitting around where we want it, but I don't know if... How do you do this? Oh, I can do a... It's because, the fasten constrains it to that face, but it's going to push out a planar. So I can do a slider, which means that it can slide along the z-axis here. Solve. Yeah, that's exactly what I want. Now, is that hitting? Yeah, it's hitting. So if I was to flip that around, my slider, would it still hit? Nope. Sick. What? Why are you broken? Flip that. Oh, it's because it just doesn't work. Straight up doesn't work. Okay, don't worry about it. I'm going to flip my slider back to how it was. And I suppose we could just like machine off this. I don't know, maybe a double? Like a double hub would be good? There is no double hub. There is no double hub of 18 tooth. Oh wait, there is. What's the difference? Oh, that's steel. Aluminium double hub. I don't know. Let's see how wide this guy is. Actually, this is, yeah, that's actually steel, so yeah, aluminium 18 tooth is a bit, I don't know. Let's see. How wide is this guy? Our friend over here. Let's isolate him. Measure him out. 9.1676. They're all 9.53. The double hub's even wider. You know what? No, actually, I don't know. Oh. Wait, is that right? That's not even right. Oh my god. Are you kidding me? That needs to sit planar in a different way. Oh, that's pretty funny. Stressing out about nothing. Make that planar. Solve. Yes, please. Now, does it hit? No, it doesn't hit. Beautiful. That's exactly what I want. Now, I'm kind of trying to finish in time. We're already 37 minutes in. But you would put a spacer in here, in the final thing. Yeah. Now we can put our motor over here. Motor. Wait, what am I doing? Vortex. Simplified model. Always just use the Falcon spline instead of the Kraken spline. They look kind of similar, but they're not the same. Now we gotta think of like how we want our wires to go. So let me think. Our wires are gonna like come up along here and down. So we want, I think we want our wires to point up, right? So I'm gonna do a revolute with this against this. And then I can spin this around to where, approximately where I want it, right? Something like that. So yeah, those holes are gonna line up. So I'll do a revolute again. Bang, bang. Done. Not happy. It is not happy at all. Why aren't you happy? Cylindrical fixed it. Okay. Yeah, also not quite what I want. I'm gonna rotate this guy another 90 degrees. Oh god. That is annoying as hell. Rotate him like that. probably what I want. Where's cylindrical, bang, bang, tick. Okay, so now our wires are going to come up and run along that edge. Yeah, so then I can put in like the pinion. It's going to be a 12 tooth pulley. That guy. Fasten him to, well, I guess we can fasten that to that. We put like spaces in a bolt here, don't worry about cutting that now. Yeah, and then how long do I have left? Say like 5 minutes or so. Now we can put in like our rollers. Alright, I'll make connectors. Now we can put in our rollers. Our rollers, we're just going to use like a configurable one that I found online. And that's kind of looks like this. But essentially, in order to put that into your CAD, I'll leave the link in the description. Looks like this. In order to put that into your CAD, you just go to like other documents, you paste the URL, configurable roller, right? Now our length. Oh, what's our length going to be? Okay, we'll just make that like 700 for now and change that later when we've got the plate in. Okay, so our tube OD is probably the next most important one. And that's supposed to be 31.75 mil. 75 mil. And because I've got a pulley, I'm going to have a pulley here that's going to pick up this belt. And then over here, I'm going to have the next pulley that goes down to the next roller, and then over here, the next one. Now what that means is the first roller, the first two rollers are going to have pulleys on either side. So they're going to have two pulleys like that, two end caps. They're going to be 18 tooth, like we said before, I think we did. Actually, what I'll do is, what do we say? Forgot what we said the first one is going to be. Oh wait, that's going to be in here. Let me just generate that real quick, and then we can edit that later. But I don't remember like the first reduction. Let that insert. Could put a spacer there. Do that soon. Okay, so I'll chuck that in. See, it's actually, so what I wanted to show you actually is that it's broken. That's because our tube is too small for this specific script. So what I'll do is I'll just change the configuration to be 2 inches OD. Like that. And then what I'll do in here is I need to also make these 2 inches. 2 in. Made a bit bigger. Now the positions are kind of wrong, but I guess we can like play with them a bit. 340 maybe. 340. Better. This one. 160. Better. Version that. Create. Did I not fix it? Could have sworn that that was the issue. If I make this bigger, does it get happy? you know, it's not designed to go to a certain size. Usually teams will have like 2-inch rollers. Yeah, it was just the size of the pulley. So we'll have to go back into recalc and change that. But yeah. What I wanted to check is I wanted to check that one. That's for the arm. Oh no, I forgot to I forgot to record what this belt pulley situation is. I believe that was a 24. I'm gonna leave that as a 24 for now. But 24 might still be a bit quick. I might want to go to like 3-to-1 or a 4-to-1. 4-to-1's a bit extensive actually with pulleys, but 3-to-1 could work. Yeah. So I'll put that one there. Solve. I'll leave that as 24. We'll go back into recalc and fix that up later. Put that one in here as well. And last one. Actually, this one is going to be a bit different because I only need one pulley. You've got belt going there, and the last belt being like the left. Okay. So I'll make sure the right has nothing. None. Fasten. Okay. I'm gonna leave it at that for now. I suppose in the next episode we'll put in our belts, we'll put in the chain, we'll put in the shafts, you know, the shaft that goes all along here, and we'll put in the other pieces, the other plates. The next episode shouldn't be too long. Yeah, almost done. Exciting. Okay, see ya.